So hi all, welcome to UCGIS Week 2025. This is our Environmental Geography Lightning Talk series. So in this session, we have a series of 6 presenters who will present. You can ask your questions in the chat along the way. We will hold all questions until the end of the session for our guests today. Just as a reminder, we do have a code of conduct for UCGIS Week, and so Christy will post that in, but just to keep that in mind of our presenters and just respectful of all of those that are here today. So without further ado, thank you for the Environmental Geography Lightning Talks. And Jackson, I'll turn it over to you to share your screen and get us started.
All right. Thank you, Amy. Hi, everyone. Looks like my screen is shared. So I'll get started. My name is Jackson Coldiron. I'm a master's student at the University of California, Santa Barbara, specifically the Bren School of Environmental Science and Management. And with my advisors, Sophie Rohr and Zoe Pirat, we have been looking into drought's impact on crop production in Iowa. So why are we focusing on Iowa? Well, Iowa produces a lot of food. It is one of the most agriculturally productive states in the US, responsible for roughly 15 to 70% of the US corn production and about 13% of soybean production. Nearly 85% of the state is farmland or cropland, but Iowa is also experiencing increasing drought as well. So the time series on the bottom here shows the US drought monitor data across all of Iowa. Darker orange and red areas indicate more intense drought classifications. And you can see in the last 5 years, there's been an increase in these more intense droughts. So these two factors here make Iowa an interesting case study for this work. In order to quantify crop production in this research, we are looking to solar-induced chlorophyll fluorescence, also known as SIF. SIF is a faint red glow released by chlorophyll during photosynthesis, and it acts as a direct signal of plant activity. And unlike most greenness indices, it responds almost immediately to stress. And the nice thing about SIF is we can measure this from space with satellites like OCO2 and OCO3. And because SIF is so tightly linked to carbon uptake and gross primary productivity, higher SIF means higher photosynthesis. It's also an ideal measurement when investigating drought and irrigation research, as it reflects true photosynthesis instead of surface greenness and other indices, and it is not as sensitive to clouds, paved surfaces, wet surfaces, or soils. So that brings us to our guiding question, which is, can SIF help us detect crop production changes as a result of drought? And to give you some spatial context, this animation here shows monthly SIF across Iowa for the past decade. Brighter values indicate higher photosynthetic activity, and you can really start to see this consistent seasonal pattern each year. SIF ramps up kind of in the late spring, peaks sharply in June and July during the peak growth season, and then drops off after the harvest season at the end of the summer into the fall. This is another animation here that's starting to show just the agricultural areas within Iowa. If we want to take a look at SIF temporally across Iowa, this plot here shows SIF anomalies for Iowa in the past decade. So on the y-axis here, you have the SIF anomalies. Anything above 0 indicates higher than normal photosynthetic activity. Values below 0 indicate lower activity. You can see in the wet years indicated by these blue bars, there are some strong positive spikes in SIF, but there's also a lot of strong negative SIF anomalies as well. And then on the right here, we have the drought years, which shows a much more muted variability with surprisingly few extreme negative drops. So kind of a key takeaway is that SIF, when we look at it in a time series averaged across the whole state, isn't necessarily responding to drought in a uniformly strong way. Now, when we look at it spatially, these maps here compare July SIF across Iowa in an average year on the left, a wet year, 2019, in the middle, and a drought year, 2023, on the right. An agricultural mask is applied, so we are only seeing cropland SIF represented here. Across all three of these maps, you see consistently high SIF in the same geographic areas, kind of showing again that crop productivity is remaining strong even under drought. And what's striking here is that even in some regions in 2023, which is the drought year, we see an increase in SIF compared to the normal or average value, reinforcing again that drought does not uniformly suppress productivity in these examples. And kind of the spatial variation is starting to matter a little bit more. SIF helps us reveal those pockets of resilience. Now, these maps are showing SIF Z-scores and drought conditions side by side during 2023, which is that drought year I had mentioned earlier. So a SIF Z-score is going to tell us how far a pixel's photosynthesis is from its normal value for that month. So the negative values in blue mean lower than usual activity, and positive values in red mean higher than usual activity. So as we go through 2023, we see that SIF is still remaining strong, even when these kind of more intense droughts start to appear. There's one 2-week instance here where we see a drop in SIF corresponding to those areas of intense drought, but it quickly recovers in the preceding months. So even though much of Iowa in this case is in moderate to severe drought, we only see that brief localized period where SIF drops below its normal range. And we're seeing that these negative anomalies aren't persisting. SIF is bouncing back pretty quickly. And this again suggesting crop productivity is more resilient to drought classification alone than drought classification alone would seem to imply. This figure is, again, reiterating this point. It's showing the SIF Z-scores distributed across the different drought categories in 2023. So each box represents the spread of SIF anomalies for pixels falling into that specific drought level. And you can see there aren't really any meaningful differences in these SIF Z-scores, even with the increased drought intensity. Once again, we see that drought doesn't seem to affect SIF in a strong linear way. And if that's not taking place, what could be contributing to this lack of SIF response? Well, one idea is irrigation. Now, irrigation has been steadily increasing in Iowa, with water use permits rising about 1% every year for the past decade. And overall irrigated acreage has grown up roughly 55% from just over 700,000 acres in 2012 to over 1.2 million acres in 2022. While Iowa is still primarily rain-fed, it's clear that irrigation is becoming more of a common strategy as drought pressure increases. And with farmers increasingly relying on irrigation, this puts additional pressure on Iowa's major aquifers, which we are very much aware here in California. But at the same time, more irrigation means more evapotranspiration from crops, leading to this phenomenon called corn sweat. This is where the water vapor that is released by corn crops on hot, sunny days contributes to rising humidity, making the air feel much hotter. So this increased irrigation solves one problem in the short term. It maintains crop productivity, but it creates these new challenges: groundwater stress and amplified atmospheric moisture during extreme heat. And we are really interested in looking more into this idea of corn sweat in our further research. So what we've done so far is investigate these SIF patterns with drought. How is drought impacting agricultural productivity? What we want to do next is start to quantify this human water use or irrigation during drought, see where are crops irrigated and how much is irrigated. Then we can start to quantify that increase in feels like temperature. And hopefully we can get an idea of how much irrigation is contributing to this corn sweat and how much the corn sweat how much hotter the corn sweat is making it feel during drought. And with that, thank you very much for listening.
Thank you, Jackson. And as we stated up front, we'll hold all questions until the end. You can put them in the chat at any point, but fascinating. So up next, we have Elijah. Elijah, go ahead and share your screen.
Thank you. Okay. You guys see that okay?
Yes, now we can see it.
Okay, one second. I'm just trying to. One second. Okay. Can you still see the story map screen?
We are seeing, no, it just looks like your map viewer of the Elwood Marine Terminal
Okay.
Restoration Project.
Okay, that's good. Okay. I kind of got to split my screens here. Is it still full screen? I'm sorry.
No, now it's like a modified screen of the Elwood Marine Terminal.
Okay, sorry. One second. Oops. Sorry, guys.
No
Okay.
worries.
How does that look?
We can see it same. Yeah, that's the one we're expected to see.
Okay. Well, I'm just gonna introduce myself. My name's Elijah Trick. I'm an intern at the Cheadle Center for Biodiversity and Ecological Restoration at UCSB. I'm an undergrad in geography in my fourth year, and the rest of my team, my supervisor Jeremiah Bender, can't be here today because they're out doing field work right now at the locations we're going to be talking about. But we're just going to kind of talk about some of the work we've been doing there, some of the restoration work, why it's important, and how we're using some GIS tools to kind of integrate with our monitoring and the steps that we're planning to take it further. The center is part of the Office of Research, and its mission is to preserve and enhance our natural heritage through research, restoration, and conservation. They do this by managing campus land, studying local species, and maintaining natural history collections. The center oversees more than 340 acres of open space stretching from Elwood Mesa to the Goleta Slough. These lands include oak woodland, coastal sage scrub, grasslands, and wetlands. They support habitat conservation, restoration projects, and sustainable stormwater management. By connecting these habitats with local watersheds, the center helps maintain wildlife corridors and supports the long-term health and the long-term health and the ecosystems of the region. I'd like to first talk about the Elwood Marine Terminal restoration, which is the little map I have going here. One of the projects I've been involved with is restoring the Elwood Marine Terminal right next to the North Campus open space and Elwood Mesa. With the help of the contractors, the center has removed old oil storage tanks, pipelines, buildings, and we've been screening trees. And this has opened up 360-degree ocean and mountain views there. Um, Overall, the restoration plan includes rebuilding a historic high point that was flattened in 1929 and restoring native habitats like grasses, wetlands, scrub, woodlands, and coastal dunes. To track the progress, the center conducts quarterly photo monitoring um, days. Each photo point is mapped in ArcGIS using a geo-GPS system, and the camera direction is recorded so the photos can be taken from the same spot over time and help with the monitoring process. This allows for clear comparisons of structure removal, grading changes, and plant growth. As part of my internship, I helped create an interactive web map that shows where the photos are taken and links directly to the images in our database. This makes it easy for anybody in the public to see how the landscape is changing over time from plant growth to removal of old structures. And I'll show you guys over here. So you can pick any of these points. We'll do this one, site point 7, and it pulls up the point name, the link to the photos, and then the photo orientations that were taken there. So you click that, and it takes you over here. If you guys can see this okay, let me know if anything happens. My computer's kind of slow. Let's see. Okay. So it pulls this up. I'm just gonna go like this for now. And it pulls up the photos that were taken. So these were taken in October 2023. You can see some of the structures that were there. And you can kind of see how the landscape looked at that time. And then we have the photos from April 2024 after the structures. Well, actually, they haven't been taken down yet. Some of them have more updated photos, but it just shows the overall progress of the tree monitoring and the restoration. Let me see if I can find a better point. Yeah, but it shows how our progress has been with monitoring this area, and how it's moving forwards. And it's publicly available, so anybody can access this. And we wanted to make it easy for the public to be a part of the monitoring process. And then next, I want to talk about the Elwood Monarch Grove Tree Planting Program. So this one might get a little scrunched. But another project I've been working on is the restoration of the monarch butterfly grove at Elwood Mesa. Monarch butterflies are a symbol of Goleta, and they're facing serious challenges due to habitat loss, drought, and pesticides. Key habitat for the monarchs is the butterfly grove, where they migrate each fall to spend several months in the coastal eucalyptus forest. But this habitat is under serious threat from climate change and other environmental degradation. The severe drought from 2012 to 2016, the worst in over 1,200 years, devastated the eucalyptus trees at Elwood. These trees are essential for monarch overwintering because they grow taller than most native trees and provide the branching and canopy structure that the monarchs need to cluster safely during the winter time. The drought caused a significant loss of canopy cover, reducing overall habitat and leaving the grove more exposed to strong winds. This threatens the delicate conditions that monarchs rely on to overwinter successfully. The city of Goleta has a habitat management plan to restore the grove. This includes planting new eucalyptus trees and native plants, improving irrigation, creating trails and viewing areas, protecting the wildlife, and reducing wildfire risk. As part of my internship, I've been creating web maps to show where the trees are being planted and tracks annual monitoring results. These trees are monitored by the center every October, during which they record tree height, diameter, and overall health, scored from 1 to the most vigorous and 4 for the dead trees. Um, and you can see that over here. These are all the individual trees that have been planted. And then on the right side, we have like a little dashboard of the trees that we have monitored since last October. I don't think all the trees have been completely monitored yet. Some of them are already there, but we're monitoring the ones that we've planted and then monitoring the growth of their change over time. But yeah, it's another public dashboard that anyone can go onto and look at to be a part of the monitoring process. And I believe that the next steps we're taking are kind of creating a way to integrate Survey 123 into this so that we can kind of have live updates and we can have teams of volunteers and researchers go out and update the height, the diameter, and the overall health of these trees. Um, and we can kind of have a more integrated system that will be beneficial for the monitoring program. Um, my next project will be a web map that aggregates data for all native trees that the center has planted on campus lands. This includes coastal live oaks, white alders, western sycamores, cottonwoods, and willows. These are spread across campus from the campus lagoon to the North Campus open space and Elwood Marine Terminal, and we're really excited to get started on that and hopefully kind of take the ideas that we have in this dashboard and the photo monitoring and kind of bring it all together, bring in some Survey 123 and volunteer teams to help our researchers get a better idea of the overall health of these restoration areas. If you guys have any questions, I can drop my email in the chat, and feel free to reach out. I'd love to get in touch. But thank you guys.
Thanks, Elijah, for that wonderful presentation. Wonderful. So our next speaker is Robert. Robert, we'll have Elijah stop sharing and you can go ahead and share.
Great. Thank you. Can you see my screen?
Yes, we can see it.
And do you only see the PowerPoint portion of it?
Yep, only the PowerPoint.
Perfect. All right. Well, hi, everyone. My name is Robert Rainey, and I graduated last year from UCLA from a professional doctorate program, which is why I have this kind of funny D period ENV period. So basically, what I'm going to share is some of the work that I did for that program around informing a fallowing program using remotely sensed data. So just for some quick background, so as part of the Inflation Reduction Act back in 2022, USBR set aside funding for conservation along the Colorado River. And this was in response to the fact that there'd been a long drought and Lake Mead and Lake Powell were getting really low, record low. And so part of this funding was for specifically fallowing along the Colorado River. And if you're not familiar with fallowing, it's just a term used for taking fields out of production and leaving them idle. Now, historically, fallowing is assumed to be 100% efficient, basically meaning that once you take a field out of production, all the water that it was using is now being saved, which we kind of expect that to not be completely true, but at big agricultural district levels, and just with historical data, we haven't really been able to challenge that very well. And so what we need is field level water use measurement data. And in this case, I'm using evapotranspiration data from OpenET to try to better understand the water use on these fallowed fields. So just to kind of introduce the concept of ET a little bit more, and Jackson actually already mentioned it, but in the case of where I'm looking at, picture a field getting flood irrigated, so a bunch of water is coming onto that field. Not all of it's being used, and some of it's flowing off. In my case, it's flowing back into the Colorado River. And so you can think of the actual water use of that field as the crop water use, which is essentially the transpiration, and then the field evaporation. And combine those together, you have your evapotranspiration. So one question you might have is this ET data accurate? And I think in this case, we're going to say that it's useful and accurate enough. So what I'm showing here is kind of the total water use in the district as measured by USBR in red. And then in the blue is one of the ET models, which is basically measuring all the ET across the district at the field level summed up. And you can see that there's pretty good alignment between the two. There are these kind of weird negative consumptive uses on USBR side, which is hard to explain, but if you can picture these kind of cutting down the tops, the peaks, you can see that these might even come more into alignment. And just as a reminder, programs generally assume that fallowing programs are using zero consumptive water. But when you look at the ET data, we see that that's probably not the case. Here I'm showing some distribution curves of water use for a few crops. So on the x-axis, we have water use from 0 to 7 acre feet per acre per year. In green, here's our alfalfa, which is peaking or has a median right around 5. And that's kind of what we'd expect out in this desert region. Our fallowed fields have a median right around 1. And what's pretty interesting here is like this, there's quite a good number of fields that have higher water use. And that's where we're really interested in. We'd like to understand kind of what are the factors that are creating this higher water use on the fallowed fields, and could we potentially mitigate that water use? Because the whole point of paying for fallowing is to save water. And that's basically my research question. Can we identify factors that correlate to higher water use on fallowed fields with the goal of making program recommendations? And just to show you what these fallowed fields kind of look like, here I have 2 examples. On the left side, you have a fallowed field surrounded by alfalfa. And there's a break between these fields. which isn't the case on the right side where you have a fallowed field that's essentially on the same greater field as an alfalfa field. There's like no physical barrier in this case. And what I'm showing are two fields that when you look at the water use, these come up as like the higher water using fallowed fields, as you might expect. We basically tried to get a more mathematical answer to this. I built the following variables. I looked at what's the average adjacent field ET for every single fallowed field. Is that field next to a canal? How big is the field? And how old is the field? How long has it been fallowed? Because there might be some like latent water when it was taken out of production contributing to that ET. And then perform some regressions between these variables and fallowed field ET. But one thing I learned in this that I was most excited to talk about was this concept of spatial weighting. And I had no idea what this was before, but I think it is pretty cool and potentially useful for everyone else. But basically, spatial weighting relates spatial objects or just shapefiles, whatever, to each other. And they use chess terminology for this. So here I'm showing two examples, a rook's weighting scheme and a queen's weighting scheme. So picture this as like 9 fields. Rook's weighting basically connects the fields that have shared borders, whereas a queen's weighting scheme, you're connecting shared borders and vertexes, like any corner that touches, you're creating connections between those. There's also like a bishop's weighting scheme and other ways to do this. In my case, I just did a rook's weighting scheme, so all fields that are sharing a border are connected. And when you do that, you basically produce what's called a spatial weights matrix over here. And I'm just going to really quickly walk through this. Basically, what this is saying is field A is connected to field B, C, D, and E. So it gets ones in all those. Field B is connected to field A. And I didn't finish making this out, but top left is field F, top right's field G, and then so on and so forth. So you're basically creating this like spatial matrix that allows you to then compute what's called lag variables. And I'll just show what that looks like. So here we have our 5 fields together. And field 1 in the middle has an ET of 1. That's our fallowed field in this example, surrounded by alfalfa fields of having ET of 5 and 4. So the spatial lag in this case, the middle field becomes a 4.5. That's the average of its surrounding fields. And then those surrounding fields all get a 1 because they're only connected to that middle field. That was probably a lot too fast, but I thought it was the only way I could do this quickly. And I thought it was interesting. If you want to like read more about it, this URL right here, I found super useful. Basically, to get to results, I found that all the variables except canal adjacency was correlated with fallowed field ET. Here I'm showing that like as the average surrounding field ET goes up to the right, the fallowed field ET also goes up. There's some correlation there. It's not amazing. And basically, to conclude, I did find variables that are correlated with fallowed field ET, and they're all actionable, meaning that a program could say, if you're going to put a fallowed field in, avoid putting them in the middle of alfalfa fields, which is kind of expected. And we know that there's other factors like groundwater depth impacting ET. There's also like confounding probably going on between these variables. So to really like suss out what's driving the ET, we need further work. But overall, from a program standpoint, they already require fallowed fields to be disked to keep plants from growing. So I think these are also reasonable requirements to try to avoid that higher fallowed field water use. And that's all I've got.
Thank you, Robert. Great presentation. So again, for those that are joining or new, ask questions in the chat. We'll come to the questions at the very end of all of our speakers. But next up, Sarah, we'll turn it over to you.
Okay. Are you all able to see my screen?
Yes, there it is.
Okay. Hi everyone. My name is Sarah Sarpati-Epstein. I'm a master's student at the UC Berkeley Energy and Resources Group, and I am excited to share a little bit with you all today about my ongoing research, which is titled Agrivoltaics Suitability, Multi-Criteria Decision-Making at the Food, Energy, Water Nexus. So just to get us on the same page, when we say agrivoltaics, what are we talking about? For the purposes of this project, it's the co-location of crop agriculture and solar photovoltaic panels, which is what we're seeing in this image on the right. The image on the left is sometimes referred to as a quote solar farm, and that is not what we're talking about in terms of agrivoltaics. And just to note that the co-location with animal agriculture is an emerging and exciting field, but not what we're considering for this project. So we're focused on crop agriculture. Um, and so my research questions, I have four broadly, but I'll focus on the first two here today, which is where in California is most suitable for agrivoltaics, and how does stakeholder input alter the geographic distribution of suitable land? So just a little bit of context. We've already heard about some of these themes today, so it's exciting to hear the connections, but as I'm sure many of you are aware, groundwater overdraft and the Sustainable Groundwater Management Act, sometimes referred to as SGMA, are both dramatically changing California agriculture. So what we see here in this image are almond trees that have been ripped out because of lack of access to irrigation water, and the difficulty in sustaining orchards in that environment. And so because of this, which is just one representative example of large-scale changes in California agriculture, and because of these changes, the Department of Conservation has launched a program called the Multi-Benefit Land Repurposing Program, which is a block grant that attempts to ameliorate the potential negative impacts of ad hoc land repurposing and fallowing throughout overdraft basins throughout the state. And this is connected to agrivoltaics through this theme of evapotranspiration that we've been hearing about. Because agrivoltaics has a potential water conservation benefit through the shading of the panels. So there have been some exciting early results about agrivoltaics water conservation benefits. Soil moisture retention has been noted to be improved by 15%, crop water consumption reduced by 30 to 40%, and biomass under the shading of the panels was comparable with 50% less water than that same crop in full sun. And this is happening via two mechanisms: reduced evapotranspiration and enhanced soil moisture retention. And so the last piece of context that we need to know is that agrivoltaics is really pretty new for California. This is a map from the National Renewable Energy Laboratory's INSPIRE program, which is their agrivoltaics program, that it's mapping all crop agrivoltaics projects in the nation. And there are 3 sites that are mapped here in California, but 2 of those are university test sites, and one is a very small vertical bifacial install, which is not what we're talking about because we're focused on the shading of those from those panels. So this leads us to wonder, where in California should we be focusing on for pilot projects, which is what my project aims to create, which is a really usable tool for practitioners, community members, grant recipients of the land repurposing grant to use to understand if agrivoltaics is useful in their community as part of this repurposing effort. And so it's just important for me to note that this tool is being created in a repurposing context when communities are already thinking about and planning for the future of their land. It's not meant to be an indication that all mapped farmland should be fair game for solar development, and it's not meant to indicate that agrivoltaics should roll out on all suitable land tomorrow. We're talking about pilot project selection. So to get to the maps, what you're seeing here is I've mapped all, the extent of all this mapping is crop agricultural land in the state. On the left is with no weights, so all suitability criteria treated equally. And then on the right is the weighted output, and I'll talk a little bit about the weighting process in the future. So we see a lot of clustering of suitable land in the southern San Joaquin Valley, in both the weighted and unweighted maps, as well as in the Central Coast and Salinas Valley regions. And then just to zoom in and ground this a little bit, so I mentioned that I'm hoping that, my goal for this project is that this tool is really usable for folks who are actively thinking about repurposing. And so part of that, I've been working with the grant recipients in the Merced Basin. So we see here on the California map, Merced is outlined in blue, so it's in the sort of south central Valley. And they have an online mapping tool as part of their multi-benefit land repurposing program for community members and decision makers to use. And they'll be integrating my agrivoltaics suitability output. And they wanted to do this at a mile by mile square resolution. So I've aggregated, my original data was 30 by 30 meters, and I've aggregated it into mile by mile for them. And this tool will be incorporated for the Merced Basin in their online mapping. And then to generate the weights, I used the analytical hierarchy process, which involved interviewing 8 experts using a pairwise comparison matrix method. And so what you're seeing here on the left is the 10 input criteria in no particular order, and these were generated through a literature review. And then on the right is after using the AHP process, these are the resulting ranks. So the AHP also results in weights that I used in the weighted suitability or the weighted sum program. But what you're seeing here is just a little bit more interpretable, and these are the output rankings. So you see distance to grid, permitting zoning, crop type really rising to the top, and things like slope and aspect being a little bit devalued. So one of the questions I'm interested in answering is how this input from these 8 experts impacts the results of suitability. So what we see here in blue is areas that with the weighting, the suitability increased, and in the brown, their suitability decreased in the weighting. And I know it's a little bit hard to see in this full state picture, so we'll zoom in on 2 regions that really saw some significant change after the weights were applied. On the left is the Salinas Valley that became a lot more suitable once the weights were applied, and on the right is Fresno County. And of course, there are lots of interactions at play, but I can theorize about why this might be. The Salinas Valley is less sunny than other agricultural regions in the state, but GHI or irradiance or how sunny is a place was actually sort of lower down on the ranking in the weighting process. And this was coming from experts saying things like, we're considering developing projects in Wisconsin. The entirety of the state of California is sunny enough for solar to make sense. And so that might be why we're seeing the Salinas Valley rise in suitability. And then what you're seeing here on the right is basically a rigid outline of Fresno County. And one of the things that really rose to the top in the ranking process was permitting and zoning. And one of the major considerations in that criteria was the Williamson Act, which is a state agricultural easement that's governed on a county level. And the Fresno County has on the books a law that when panels are installed on agricultural land, their Williamson Act easements need to be canceled. So that's seen as sort of unfriendly for this co-location schema. And so, that I think is probably why Fresno County is showing as a lot less suitable once the weights were applied. But that being said, I want to leave you with the fact that California is still looking pretty good for agrivoltaics, even though we saw, Fresno County really decrease in suitability with those weights. Here it is in the weighted suitability map, and much of that Westlands Water District, which is in western Fresno County, is still moderately suitable for agrivoltaics. So we're excited about where pilot projects might go. Thank you.
Thank you, Sarah. So it looks like we may have a slight change in our schedule. It looks like we do not have our next speaker, giving them one more chance. And again, we'll hold questions for all of our speakers until the end. But it looks like we will move on next to Mary, who has just joined us from class. So thank you, Mary, for making it. We'll go ahead and start. And if our speaker does show up, we'll get to them in here at the end. So Mary, it's all you.
Great. Can everyone hear me okay?
Yep. And we can see your screen.
Thank you so much. All right, so my presentation will be on spatial and cultural storytelling, with an emphasis on mapping Asian American narratives through GIS, oral history, and virtual reality. A little bit about the program that I'm going to be describing today. So the Asian American Youth Leaders Program, which is housed at the South Coast Chinese Cultural Center in Irvine, is a place where we really aim to cultivate the next generation of Asian American leaders. So we work with middle school, high school, and college students to explore Asian American studies and community building. This program was really built in partnership between UC Irvine and a nonprofit organization in Orange County, the South Coast Chinese Cultural Center, as a way for students to really find a way to kind of explore more about their culture, their identity. And I became their program director a couple of years back. And a little bit more about the team itself. So hi, I'm Mary, I'm the program director. I'm also the oral history administrative lead for the specific project. We also have two other instructors, Dr. Fuko Kiyama and Trin Dang, both of whom are the oral history instructors. Um, Rainey, Michelle, and Rena, they are also mainly working on the VR cohort. All six of us are either UCI alum or we are currently graduate students at UC Irvine or undergraduate students. I myself am a graduate student in the health sciences department. Fuko is currently a postdoc in the School of Education. Trin is in the School of Global Studies. Rainey has his master's from the Urban Planning and Public Policy. And Michelle and Rena are both currently either graduated out of software engineering and or they are currently graduating out of game design and interactive media. So with all of our diverse backgrounds, we came together and we built a program for the high school and college students to build out a oral history and virtual reality kind of dual tandem project where these high school students and college students are answering the question, when I grow up, I want to be. And this really came about because the students came to us and kind of said, every time we want to look for someone who is representative of who we are, right? And in any kind of field, it's kind of hard to find these people, and maybe they're not really super willing to share their experiences. And so we went ahead and put together this project for the students to be able to identify Asian Americans locally who would be able to share their experiences about what their career fields are like, and to really help these students understand what they would be getting into in college and beyond that. So students are interviewing an Asian American UC Irvine student, a current working professional in Orange County, and then they're also doing some research in the archives to look at people in the past who may have been working in these career fields and really set the groundwork for some of these fields. These stories are recorded and then mapped through different softwares. So the project goals overall is to first off develop a database or repository of Asian Americans in different fields in order for students to be able to research and see themselves represented across these various fields. Students have picked different fields including drama, medicine, psychology, social ecology. They really, took a look at all the different fields available to them. And students were really willing to take a look at something they never thought about before either. All of these stories will be mapped out and documented, including the migration and immigration stories of students and professionals who currently reside in Orange County. And then last but not least, the virtual reality portion of this program is really designed in order to be able to provide students an opportunity to explore these professions using multimedia tools and really experience some of the simulations that they may be able to have while working in that career field, and also for them to kind of mock up and experience a day in the life of what some of these people are experiencing from going from home to work to all their other extracurriculars and back. So a little bit more about the oral history project in general. The timeline itself is kind of broken up into a couple of blocks. And so initially the students really spent some time looking at oral histories. What are oral histories? Doing a training and a refresher. And we did this with the UCI Southeast Asian Archive. So thank you to them. And then in the past 2 months previously, they identified archives, students, and professionals across Orange County. This was the most interesting part because they really learned how to network and really learned how to make connections and learn how to ask people to interview. But they're currently in the process of conducting these interviews right now. And so we've actually had our first couple, and the students had an absolute blast learning about their experiences. And a lot of these professionals really shared like a day in their life and kind of how they got to where they are now. Looking forward into next year, the process will be including developing their story maps for all of these individuals, and then making physical products and maps for display, as well as their community presentations. So in these pictures here are some of the story maps that we kind of mocked up with them previously. Some of these students have already interviewed and they started making these story maps already. And so we have an individual here who started in Busan, South Korea, and she's currently located in Irvine now. The students for their physical maps will also be mapping all of these story maps all together onto a physical map themselves to really highlight all the intersectionalities of where people may have crossed at different points in time. We've discovered previously that some of our interviewers happen to be at the same refugee camps at the same time, and they just never realized it. And they somehow also both ended up in Orange County, kind of in similar work as well. So it's really a chance for the students to understand migration patterns and history and Asian American history, but then also for them to really find a way to see how people can migrate and immigrate over time and how they've landed in Orange County today in their current roles. Looking at the virtual reality project. So the virtual reality project was really a way for us to get students engaged in a more multimedia manner. The initial point of the project was really for them to see how we can integrate technology into a lot of these mapping activities. And so the students initially just really got to learn how to utilize the VR technology. We're using the Meta Quest 3 headsets. And the students had a blast, just going in there trying to see each other in different spaces. We have students in this specific program who are currently in Orange County, but maybe due to familial issues and whatnot, they're currently participating with us from the East Coast as well, and even internationally. So it's really been a great way for us to continuously involve these students in our programs despite their moves. They're currently in the process of getting familiar with programs such as Spatial and Hyperskill and really understand basic design and accessibility concepts. So with that being said, for example, the students in the left-hand corner, they started to learn about how to put some of these story maps into VR itself. So how did we actually move some of these images and some of these mechanisms into VR? How are we playing around with the maps? How do we display them properly? They're also looking at Spatial to see how design is a really important aspect in terms of how people can see and understand maps. And then this appears a little simulation of how some of the professionals that they have already interviewed, what their days in the life look like, and they can actually walk around and interact with some of the things inside of those spaces. Looking forward into next year, the students will be bringing the rest of the oral history project into the VR space, including all of the maps, all of the simulations, any photos and memorabilia that was sent in by the family members as well. And then last but not least, in May, June of next year, they will be doing a combined presentation with our oral history cohort. So in conclusion, our students are really using a multitude of tools and softwares to better understand migration and immigration patterns and stories for different Asian Americans at UC Irvine itself and within the local Orange County area. With the help of virtual reality and the support of a lot of different programs at UCI and externally at local nonprofits, we've really been able to make our work more accessible to students and provide opportunities for them to understand immigration, migration through story maps and other mapping tools, and to better engage with information and materials. Thank you.
Thank you, Mary. And thank you to all of our presenters today. So I do not see our last presenter here in the chat. So I'm going to ask that all of our presenters come back on camera for the Q&A session. And Christy, am I right? We don't see our last speaker?
We do not.
Okay, thank you for confirming. So I think we'll open it up. If anyone has a question, feel free to put it in chat. Feel free to also raise your hand and we can call on you and you can unmute and ask your question as well. I do have some questions, but I also want to open it up to anyone else.
We also did have one of our speakers have to leave for class. So you may need to use Elijah's email to contact him if you have any questions or comments.
Okay, I gave it long enough. Mary, I'm going to start with you just as sort of the last one, but by all means, sort of feel free. So were a lot of the students who were using this and coming across story maps, was that their first exposure to sort of mapping in general, or had they had other mapping experiences? And if so, like what was their feedback on the mapping component specifically?
Yeah, so for a lot of our students, because they're in high school, so they're really their first exposure to a lot of these mapping tools and activities. We started integrating them into our other programming as well, since we are a year-round program. And so we've integrated it into our fall and our summer programs for students to really understand the importance of really visualization, right, in terms of how we use these maps and the importance of sharing this information in that way for the community to have a better understanding of what these migration patterns really look like and what these immigration stories can really look like. The students initially, I think they were a little nervous, to be honest. I think anytime a student's trying to learn a new program or software in general, there's always a very steep learning curve. But I will say the students had a really great time just starting to interact with these tools and materials. I know a lot of the students have brought these materials into their classrooms as well for their own, personal use and for presentations in the classroom and their K through 12 classrooms. And so it's been really nice. And we've been able to partner now with a couple of teachers in different school districts, as well as other nonprofits to kind of run similar programs and projects.
Wonderful. Thank you. Again, we'll give it a moment to see if anyone else has questions. So I do see one that came in for the speakers that focused on, from Samantha. So for the speakers that focused on agriculture, could you talk more about the consequences of groundwater overdraft?
I guess that could be a Jackson, Robert, or Sarah.
Sarah, do you want to touch on that with your experience with Sigma?
Sure. Yeah, I mean, the consequences of groundwater overdraft have been significant and wide-ranging, and it's from both the sort of ecological as well as agricultural and social contexts. From my research is really focused on sort of what comes next after Sigma implementation. Happened. So Sigma passed in 2014, but is sort of being like still in the process of being fully implemented as groundwater sustainability agencies like make their plans to come into compliance. So we're seeing all the need for all sorts of landscape changes. There was a very pivotal PPIC report that estimated in a worst case scenario, like 900,000 acres in the San Joaquin Valley would need to be fallowed in order to come into full Sigma compliance, as well as other like climate change related elements. So it's certainly impacting the agricultural landscape, but also, I mean, groundwater overdraft causes land subsidence. It limits access to drinking water for people who are well dependent. It impacts like groundwater dependent ecosystems, and in coastal areas, there's problems with seawater intrusion. So there are all sorts of very significant consequences of groundwater overdraft, and maybe Jackson and Robert want to comment on others.
Yeah, I'll just add, because I think for me, for a long time, I thought of like groundwater overdraft as you think of the people on wells a lot of the times, and it's like I'm in LA, a lot of us are in Southern California. We get a lot of our water from surface water, especially from the State Water Project. There's actually a lot of issues there with subsidence and the State Water Project canal basically like potentially failing in the future, which would be very, very bad. So I guess that's bad news. It's even worse of a problem on the drinking water side.
Yeah, and I think they've nailed most of the issues there. I think there's, yeah, like kind of Robert was touching on an equality issue too, because um, before there was really these guardrails put in place. It was pretty inequitable the way that the groundwater was being used. So I think that would be like a significant issue as well in terms of like who's actually getting this water and how is it equitable and inequitable.
So thank you. Sort of, I have I guess a question then for Robert, Sarah, and Jackson, thinking about that, because we saw right from Iowa and the ability, and then Sarah in your talking about, how perhaps some of these weighting or comes from, right? All of California is a solar state where it's like, no. So how much does sort of the scale at which either indices or weights are represented sort of impact down to this local? And right, Sarah, you were asked, I think, to sort of aggregate your 30-meter pixels to 1 mile race. So I don't know if the three of you can talk about that, sort of what you've learned across all of that from just others, and sort of how the scale influences either your work or how your work will then influence the scale at either the national or sort of a smaller scale.
Yeah, I think for me, it's been interesting working with different data sets, and they're all at different resolutions and different scales. So you kind of have to, there's like a give and take there, and you're kind of making some adjustments based on how you can align those different things. So I'm working with SIF data, but I'm also introducing drought data and hopefully introducing irrigation data. But the irrigation data might be at the county level, and the drought data, could be at like a municipality level, whereas like the SIF is at a finer scale. So, um, yeah, it's kind of the manipulation and the processing of the data and marrying those things together can be a compromise. So I've kind of found that to be a learning experience and an interesting process.
Yeah, something that I've been thinking about a lot, but I don't know if this is exactly what you're asking, but like the suitability index that I've created is normalized across the state of California. So we have 0 to 100 all within the state. And I think that I feel confident on doing that because so then what you're going to get is you're going to get like more or less suitable within as each pixel compares within the state. Like you're just comparing internally. And I feel comfortable doing that because there have been other sort of broader studies that have looked at either maybe like the arid West or the entire country that have shown on a really granular level that California is suitable for agrivoltaics as it compares to a broader regional or national scale. So I think going from those literature to say, I'm going to zoom in and say, if you've already established California is suitable, then where within the state are we actually talking about?
I think for me, I've seen it in the accuracy assessment side of like, so ET is like a energy balance model, and so it creates this grid across like 100,000 acres of the farmland I'm looking at. And so like the ideal way to know your ET data is accurate is like with a eddy covariance tower or flux tower, but those are expensive. And then it's like, okay, you might know one field is accurate, and you probably don't have enough money for like multiple. You don't even have enough money for like one. Um, but then with the USBR's data, they don't have anything at the field level. It's like district wide. And that was like the one graph I showed is, so the best I could do is say, okay, well, USBR has an estimate for the whole district. It's not perfect, but my best kind of accuracy assessment is to compare the ET, which is like all these fields together, to this imperfect district-wide level. And basically, I guess it's kept running into this idea of like there's no perfect, or it's very difficult to get like a perfect accuracy assessment. And sometimes you just have to be happy with good enough and making recommendations based on that.
No, I appreciate all your insights on that, right? I mean, it's that scale is always an interesting thing. Location matters, scale matters, and so it's in all of that. So, I do see we're sort of at the end of our time. So, if you do have feedback about any of the UCGIS week, Chrissy has posted a link in the chat. So please provide your feedback. Again, giving a round of applause to all of our speakers today. Thank you for taking time to share your work and to share what you're doing with the rest of the sort of UC community as well as the world. It is 4 o'clock, and so our next session is actually taking place in a separate Zoom meeting. It is the workshop on how to use the California Tree Species Range Map Atlas. So it's updated on the 2024's work. So their presentation, Clancy and team presented this morning. So if you're interested in that workshop and stepping through, join us in our other Zoom meeting. And actually, let me just post the chat link here for everyone if they would like to jump right over. Otherwise, thank you all, and we will see you. Well, let's get this. Here we go. Doesn't want to work today. Thank you all.
Thank you.